Please do not ask what our abbreviation is for legal reasons. And let's get started. Now, before we go into the details of what we have, we should introduce our team. Starting off with me, my name is Zachary Robbins, and I am the business analyst.
Yeah, hi everyone. I'm Maher Issa. I contributed with the feature and data engineering for this project.
And I'm Hilton Tribbett, and I'm the solution architect.
And I am Giovanni Gonzalez, and I was the technical lead.
Now, with the introductions out the way, let's jump right into the problem. You have tasked us with finding a solution to your problem, and that problem is that your EC2 instances simply cost too much money. You primarily use them for allowing your remote workers in the same time zone to remote in from home to do various tasks, such as approve loans, check suspicious payments, and help online banking customers. However, an investigation made us realize that development and testing EC2 instances were running 24/7, even outside of business hours, even on weekends. This is a huge money sink. There's no reason to run it for all that time, and you might be thinking, well, why don't we just turn it off and on manually? But then the problem with that is that you then have to assign staff to doing that role of turning it off and on manually. And then on top of that, not only can that be inconsistent, but it also takes up even more time out of a busy workday. Now, before we get into what our solution was, I would like to walk you through what we consider to be the three core aspects of our solution, our three main goals as well. First is to, as we mentioned in the previous slide, eliminate annual losses. Now, the first thing is we want to eliminate costs of hosting EC2 instances after hours, so that way we can just shut it off, because what's the point in hosting it if workers can't use it? The second aspect, as I was mentioning before as well, is to automate management. Now, all activations and deactivations should happen without human intervention. Finally, we want your team to be able to understand what is happening and to be able to get regular updates. So that will be another part of it as well, is to notify the operations team of all actions taken via email.
Yes, so the solution, a little bit more detail on the solution here. The solution focuses on serverless automation pipelines using AWS Lambda, EventBridge, and SNS technologies, simple notification services to streamline how SilverSafe Banking manages their EC2 instances. Instead of relying on manual shutdowns or someone taking time to turn servers on in the morning and stop running in the end of the day, we've implemented an automated policy-driven workflow. Every evening at 6 p.m., the EventBridge scheduler triggers a Lambda function that safely shuts down the designated EC2 instances. This reduces unnecessary compute costs and ensures that not paying for idle resources overnight. Then at 8 a.m., another scheduled EventBridge rule starts those same instances back up, so the team has a seamless start to their workday. Because this is serverless design, there's no infrastructure to maintain. Lambda only runs when triggered, and costs are only applied during execution time of the triggers. To keep operations transparent, we integrated the simple notification services, which send real-time alerts to the SilverSafe Banking operations team. Those are the cases when the servers are shut or powered back on. This gives IT and ultimately business users confidence that automation is working as expected and provides a clear audit trail. Overall, this approach improves efficiency, reduces operational overhead, and ensures consistent, predictable instance management without human manual intervention. So in this project, just to go into more detail with the tools and technology used, we focused on a set of AWS services that work together to automate the EC2 start and stop operations while maintaining strong security. observability and communication of the workflow. At the center is the EC2, the compute resource that we're automating the up and down times. Instead of managing these servers manually by humans, AWS Lambda is leveraged to run the lightweight Python functions that start or stop instances on demand. Again, because this is Lambda, it's serverless and there's no infrastructure to maintain. To ensure secure access, IAM provides least privilege permissions so Lambda can interact with EC2 and publish notifications appropriately without exposing unnecessary privileges to unwanted users. And EventBridge also acts as a scheduler using cron expressions to trigger the Lambda functions at exactly 6 p.m. and 8 a.m. For communication, SNS sends operational alerts to the SilverSafe banking operations team whenever the instances are started or stopped. And for more reliable email delivery, especially for transactional or high volume messages, we could extend this to SES, the simple email service, but in this case, it's likely to be overkill. CloudWatch captures all the Lambda logs and metrics so issues can be troubleshooted with verifying execution history. And finally, CloudTrail records every API call for compliance and auditing, giving a full picture of who did what and when. So just to summarize, together these services create a secure, automated, and fully auditable workflow that reduces the manual effort to ensure consistent lifecycle management. And now I'll go ahead and hand it off to Hilton, who will provide more details on the solution architecture.
Thank you, Mohair. So as you see here, you're looking at the architectural workflow. And this is just a brief overview, just to give you kind of context before we actually go into the demo, which will actually give you more in-depth knowledge of how this workflow actually interacts with each other. So our system operates on two schedules, which is one, as stated earlier, was the start of the EC2 instance. That's in the morning, and the stop of the EC2 instance in the evening. So as you can see here to the right of your screen, these are our two functions of Lambda functions that are actually starting and stopping the instance. The event bridge fires, which schedules our configuration time, and that schedule is done through prone scheduling. Our Lambda invokes the start and stop functions, which executes the EC2 instance. And we separated the Lambda functions into two different functions because it makes it easier to troubleshoot. Instead of just doing the same start and stop function in one Lambda, it makes it actually easier to actually troubleshoot if there's any issues with a start or stop function that's going on in Lambda. So that was a good troubleshooting to do that. And then next, the EC2, which is due to Boto3 SDK, calls the start and stop function. So that's the EC2 API that actually makes that call. So if you look down here, Lambda is actually, you'll see how the triggers and was it a success or failure through the CloudWatch logs. And through CloudTrail, you can actually see who implemented the Lambda, or who activated, or who actually tested the code on the Lambda. It'll give you that trigger. It'll give you the account of who did that. So we also use the SNS notifies to send email subscriptions to the operation team. And you'll see that more in the demo later in real time on how they get the email in the test that we run later. So with that, I'll pass it to Giovanni.
Thanks, Hilton. All right, now let's talk about what this actually means in dollars. Without our solution, SilverSafe Banking's EC2 instances run 24 hours a day, every single day. That's 720 hours a month per instance. At roughly 4 cents per hour across 10 instances, you're paying $299 a month, which adds up to $3,594 a year for servers that are sitting completely idle for more than half the time. With our solution, those same instances only run during business hours, 8 a.m. to 6 p.m. 10 hours a day, 300 hours a month. Same rate, same instances. That brings the monthly cost down to $124.80 and the annual cost to $1,497. The result? Silver Safe Banking saves $2,096 every year, a 58% reduction in EC2 costs. And that number doesn't even include the hidden savings from eliminating the manual shutdown process, but we'll get that on the next slide. The cost savings are the headline, but there are several other benefits worth calling out, specifically for banking environments like SilverSafe. First, zero manual intervention. Nobody on your team needs to remember to shut anything down, no dependency on a specific person, no single point of failure. If your sysadmin calls in sick, the instances still stop and start exactly on schedule. Second, your employees log in at 8 a.m. and everything is ready. No waiting, no support ticket saying the servers aren't up, no lost productivity at the start of the day. Third, and this one is important for a banking context, there's zero chance of a worker accidentally staying in a remote session after hours. The instance shuts down at 6 p.m., full stop. That's not just a convenience, it's a security control. It reduces your attack surface outside of business hours, which matters a lot when you're handling loan approvals and payment data. And finally, your monthly costs become fully predictable. Finance can budget around a known number instead of a variable bill that depends on whether someone remembered to click a button. I want to share what our team actually learned building this and what surprised us along the way. The biggest insight was how central IAM is to everything in AWS. Before Lambda could touch a single EC2 instance, we needed an explicit, correctly scoped permissions policy. Get it wrong and nothing works. Get it too broad and you create a security vulnerability. For a banking client, that distinction matters a lot. Lambda's serverless model turned out to be the perfect fit for this kind of task. It runs for about 2 seconds per execution and the cost is essentially zero. There's no server to manage, patch, or pay when it's idle. CloudWatch logs were our primary debugging tool throughout the build. Every line of output from Lambda appeared instantly, which made troubleshooting fast. On the challenges side, we hit 2 real-world surprises. First, T2 Micro is no longer free tier eligible on the newer AWS accounts. We switched to T3 Micro and it had zero impact on the project, but that's the kind of thing the documentation doesn't always warn you about up front. Second, Event Bridge schedule rules interface had migrated into a new scheduler console. The docs we were referencing hadn't caught up yet, so we had to navigate the updated workflow on the fly. Both of those were really good real-world learning moments. Our solution works today, but we're already thinking about how to make it better. Right now, the Lambda function targets specific instance IDs. A more scalable approach would be to use tag-based filtering. Any instance tagged environment equals development would be included automatically. As SilverSafe's environment grows, you wouldn't need to touch the code at all. We'd also update the schedule to run weekdays only, Monday through Friday. The current setup runs every day, including weekends, which means instances are stopping and starting even when no one's working. Switching to weekday only would save an additional 28% on top of what we're already saving. We'd add CloudWatch alarms on Lambda error rate. So if the automation ever fails to fire, the operations team gets an alert immediately instead of finding out when employees can't log in at 8 a.m. And finally, we'd integrate AWS Cost Explorer so SilverSafe can see the savings in real time on a live dashboard, not just a number in a presentation. Next, I'll pass it on to Hilton for the live demo.
Work together seamlessly to give the outcome that we're presented in this slide. So what you see here, the first thing we wanted to do was to make sure that the information can get to the operation team. So what you see here is Amazon SNS, which allows us to send emails, notifications, which will send stop and start email notifications to the operations team. And down here is the operations team email, which is the endpoint, which is the ops tech flow team. So when the instances are started, when the instances are stopped, the operation teams will automatically know that these events are happening. With that, you have the IM user. So the IM user is what actually allows you to access permissions. So we had to make Lambda have a role. So there's a difference between IM user and a role. IM user allows you to have the permissions. You got to understand that a role is a temporary identity for an AWS service. So it's kind of allows like Lambda to communicate with a certain service. So here, what you see here, we created a Lambda EC2 stop policy. And that stop policy here, as you can see, is the code, the JSON code that it gives Lambda the permission to interact with the AWS services. As you see here, you got an EC2 permission, which allows Lambda to start and stop. You see, this allows Lambda to trigger to send the SNS to our operation teams. To Silver Safe Banking's operation team, which is Ops Tech Flow. And it also allows Lambda to log the permissions, CloudWatch log permissions, which you can see the events of what happened. If you look on this schedule here, this is our event bridge. So as you can see, we have two event bridge events here, or they call them rules, scheduled rules. So we have one rule that starts at 8 a.m., which actually triggers the Lambda to start the function, and it starts the EC2. Here, as you can see, we have another scheduled rule, which is 6 p.m., which actually triggers Lambda to stop the EC2 at 6 p.m. So here, what you're seeing is our test instances for this project. So as you can see, the instances are stopped right now. We did that for a particular reason because we wanted to show in real time how the function works. So here we have two functions. As you can see, we did that for optimization purposes and troubleshooting to have the two different functions separated. In case there is an issue, we can identify it quickly. So we would like to go to the start instance, and you can see here as it loads, this is our code that allows us to start the instance. And as you can see, we're already doing optimization because we tagged it with an environment and development, so Lambda could know what EC2 instance to start and stop. So we already were starting to optimize as we went along. So if we hit test, now it says our start was successful. And if you look at the status code 200, that means success. Now there are different codes. You have 200, 300, 400, and 500 status codes. But today we're focused on 200, which means that your event has ran successfully. Now, if we go back to our instances and we refresh, you'll see now our instances is running. This is proof that our Lambda code, our start instances Lambda code function was successful. So now if we go back to functions and we go to stop our instances, you get to see how the function acts, whether it's successful when we're stopping an instance. So we hit test, you see it goes through the process, the execution process. And again, we get status code 200, which lets us know that stopping our instances was a success. And that's what we're looking for. So as you can see, our instances is running right now. We refresh, you see now our instances is stopped. So with that, if you see here, this is what we wanted to show, that we took Silver Safe's problem seriously, and we wanted to make sure that it can still survive a chaos. So we wanted to run tests to make sure that it can implement if something happened, right? And by doing that, we know that we're following AWS's best practices of reliability, operational excellence, and performance efficiency. So right, as you see here, we did a fault injection test, which is just an experiment. And doing that, what happens is, after we run the test, it will send an email to the operations team, letting them know that whether the success was a failure or completed. So here you'll see chaos engineering test report. And this report is actually sent to the operations team. And it lets them know what the report is about, what was the experiment. You see briefly here, randomly selecting one EC2, stopping the EC2 in an unexpected failure, and actually maintaining a 5-minute downtime from that to see what happened. As you can see, all status was a success. The auto recovery was a success in the process. So that was very excellent. It lets us know our key findings it sends to the team. It lets us know the chaos engineering benefits in this report. Also the monitoring and access, the API calls, the trail watch. And also what are our recommendations, right? Continue regular chaos engineering testing, expand testing. And down here, it shows the cost analysis that was expanded earlier. Also with that, we sent to engineering a second test, which is a functionability test. And in this test, we actually test whether the stop function can stop successfully, can start successfully. And we tested whether Lambda can handle 5 invocations at the same time. And you can see it passed that test. And we also have performance metrics, which is Lambda typically has to execute under 10 seconds. So with that, we wanted to see whether it can actually trigger a function efficiently and fast. So with that, they will also get this report to the operation team. So here's our CloudTrail. Like I said, CloudTrail is used to really show who or what personal identity actually was triggering these events. And as you can see in the code, it will show the account. Now, what's interesting here is you get a notification about the health of your system. So in the recovery of that one EC2 instance, all SilverServe Banking will get a notification saying that their EC2 was recovered successfully. And that's a big point. It shows when it went down in auto recovery, and it shows that it was recovered successfully. Also, one last thing, in the morning when the EC2 start up, they get an email of a morning startup to the operations team. The operations team get this email saying the instances have started, and they also get an email saying that the instances has been shut down at 6:00 p.m.
I saw you then manually, but
yes.
So could you tell us, like, when you were doing event grade, what kind of challenge you experienced? Because I saw your kind of laundry list of key learnings. So walk me through few challenges which you experienced, which took long time to figure it out.
Well, for the event bridge, the gap was the Chrome was the gap, was trying to understand the Chrome timing because of the different time zones. So for me, I had to test it and configure it to my time zone. Also linking, and trying to understand the linking aspects between the EC2 stopping and the Lambda, and trying to configure that time for them to link. So that was a little challenging, understanding that and trying to troubleshoot that so they can link properly.
Got it. So Giovanni, this question for you. First of all, you're a good presenter, Giovanni. I like your voice and the way you presented. Excellent.
Thank you.
When you were presenting, like, what do you call the current situation where it is costing X dollar, after your implementation, it will cost Y dollar. If CEO wants evidence that what you are saying is too good to be true or is a real fact, what other details you can provide?
Other than just like showing the actual savings costs, like showing what the tiers would cost. So if, like, for instance, how we calculated that savings of $2,096, you take the 10 instances by what, 4 cents an hour, 720 hours a month, that gets us up to what, $300 a month. So we would specify like what those real world costs would do and show them, okay, you have this many instances running with this many hours, but if we cut it back to just, Monday through Friday for only those 10 hours instead of running 24 hours a day, that's where we can show them those savings. And if they're going to ask like, why not 100% savings? We only said 50% savings. We still need the business hours running, so we can't shut it down all the time. So that's why we could only eliminate the cost for the 14 hours a day that they run with that they're not running when nobody's using them.
Very good. Jack, question for you. While you're communicating with your team, right, what are the few items you learn where you can say, if we do this thing as a team, collectively, we can get better and faster?
I think that sort of taking some inspiration from Scrum and Agile regarding having regular sprint meetings is absolutely phenomenal for making sure everyone's on the same page, that we can coordinate effectively, and making sure that sort of to make that balance of sort of having rapid, quick meetings where you don't go over too long. Thankfully, the 30-minute time limit on a Google Meets helps with that. But making sure to not have meetings that go over too long and to make sure you get right to the heart of what needs to be done and how can we best distribute it.
Very good. Mahir, I saw Hilton was presenting two different Lambda functions. One was start, one is stop. Did you try any time where user is logged in, user is actively working, and Lambda is stopping? Because does it have an intelligent built-in where Lambda say, oh, user is already actively working, we should not stop? Did you guys try that type of scenario?
Oh, in terms of the IAM user being the
No,
same, being
this
logged in?
EC2, that EC2 I have remote logged in, I perform SSH, or I'm doing some activity.
Oh, logged into the server itself.
And you are now stopping. Would you be able to detect that user is already logged in, the EC2 is in progress, or someone is working, we should not stop?
No, we did not test that. I did not test that, but it would show up in the cloud audit trail log.
But what do you
Yeah.
think would be a good idea that Lambda should have intelligence to detect that, yes, there is an active user, there is a in-flight operation?
Updates, like software updates or operating system updates, things like that. Yeah, that's yeah, because currently, I think, like Hilton pointed out, that with the health report, that the server would automatically try to restart with his testing example. So in that case, we wouldn't want to restart the server because of the operation updates needed. So that's a good point.
Tushar, I did have a quick thought on
Yeah.
that when we were doing this. I was thinking to myself, what if an employee like needs to work late? And I was kind of looking into it. You could do two
Odd
options.
scenarios.
They can either manually start the instance themselves if they have the EC2 permissions, or we could do like a implement override mechanism. Like you could use a Lambda function the employee can trigger via like they can go to a website and they can just trigger it from there, or send a Slack command if they use Slack, something like that, to override the Lambda function like that.
Yeah, so I have done this thing. I just tell you how I have done. So just as a FYI, what we do is we take like a time window, and then before Lambda try to stop, we do time window and see if there is a CPU or memory activity going on, or IO activity going on. If any fluctuation is noticed in 15 minutes window, then if we don't stop it. If there is a flat line, then we stop it. It means the machine is not used. Loud.
All right, thank you. This is our final project for the AWS class called the AWS EC2 scheduler. I'm Anthony. This is John. Here is our project. So the core of this project is pretty much to start and stop the EC2 using Lambda, and obviously it might be triggered by some type of event bridge, API, or whatever. And obviously, using an IAM mode to give the necessary permissions and trust policies to allow other technologies to use each other to perform the tasks. Since those are the core parts of the project, we actually made some enhancements to it to make it even more advanced. And some of the enhancements we have added were hosting this function on a step, pretty much hosting the scheduler on a static website. So integrating S3. In addition to that, we also integrated a CloudFront to this to actually allow this website to be available at edge locations. So for pretty much allow the website to be high availability. Also integrated API gateway to call to make get put calls to our Lambda functions, to the additional Lambda functions we added to it. And lastly, we also integrated DynamoDB to store the updated schedules as well as to store new schedules as well as update the schedule. Here is our pretty much architecture of our entire system. A client will access the scheduler website via CloudFront. Obviously, all the assets for this website is stored in S3. Once the user puts in their schedule for for the EC2 instances, you either go through a get call where you actually get schedules that are already stored, or where you put in updated schedule. Once that is done, our thought Lambda function will be able to either go into our database, either fetch pretty much the stored schedule, or to pretty much look into the database to figure out what it needs to do, either to fetch the stored schedules or use the newly updated schedule. From there, EventBridge will trigger this Lambda function to start or stop the EC2 instance. And once this is done, you get a notification via email pretty much the client will get a notification there. Some of the learning, some of the things we did learn in this new project was obviously how to integrate all AWS technologies from Lambda, IAM roles, EventBridge, DynamoDB. Python coding was a big learning experience for us in this. JavaScript for coding the website, thanks to John. CloudWatch, of course, to actually monitor the login and debugging of our project. Some of the key challenges we did face in this included trying to configure the IAM role so that all the technologies can communicate properly. Python coding as well was also a big issue. Was also a big challenge, especially having three different Lambda roles to start, stop, update the database as well as write into the database, and also trying to use the database DynamoDB. How data is stored and retrieved. There's also another challenge we did face this project.
Okay, so we'll have it. All right, so I'm gonna break out of the presentation and just give a little demo of what we created here. So to just try to follow the flow of the application, the user would hit our website, and our website, first of all, is stored on S3. I'm sorry. I have an S3 bucket called AWAuto. I use it for another client. It's the demo part of it here. So the website for this project is just a simple HTML file with the JavaScript and a little bit of CSS to make it look nice. To get to this, the client does go through CloudFront, so it is available on the edge locations and a little bit more responsive if it needs to be accessed throughout the country or throughout the world anywhere. In here, the majority of configuring this was just pointing it at the S3 bucket that is designed for static websites. So the origin of my CloudFront distribution is just my A3Auto website bucket, and then configuring a little bit of security from inside of here. That allowed me to get a URL, as you can see up on top here, and this URL is how we access the website going forward. This is what the website looks like. By default here, you can see that the only schedule I have is that all day we have 0 instances to keep things down. Anybody that was given access to this website, which we created because we felt, starting things at a specific time and stopping them at a specific time is a little too rigid. We wanted to give the admin of these EC2 instances the ability to determine their schedule in real time. If they need to have things run late into the night for a project or stop early for any reason, they can come in here and on a 5-minute interval, decide when they want their EC2 instances to start and stop and how many EC2 instances they want at any given time. So while I'm doing this demo, I'm going to go ahead and make a little schedule here. So it's what, 7:20 right now, my time. So that's 1900. So if I go into this here and pick 1920, which is about a minute and a half ago, we'll leave that alone. We'll add another block that picks up my stop time automatically, only lets me pick times going forward. And we'll say for the next 10 minutes, we want 4 instances. 10 minutes after that, we want 2 instances, and then we'll just shut everything down for the rest of the day. If somebody were to forget and not put the whole day in, if I try to save this, it will not allow it. So it must have the entire day accounted for. I'll drop down to the bottom here and account for the entire day, put a 0 in there. And I'll go ahead and save the schedule. So what happened here, when I first went to the page, it did do a get call to the Lambda function that we have, which I'll show you in a moment, to get the schedule from the database that's current. And then when I saved it, it did a put call to the same endpoint to store this database or this schedule into the Dynamo database. As you can, so I will show you in here that we have the API gateway set up to allow this communication. In this API gateway, we have an EC2 scheduler API with simple get and put HTTP endpoint calls. We didn't get too fancy with this. All these do is directly point to our Lambda functions. If we were to go into there, you would just see a /schedule is all that it's actually trying to do at the endpoint provided. And you can see here, this is one of the endpoints. If I go to it here, you can see it returns JSON, and this does match up with the schedule I just created. Outside of this, we can go into the Lambda at this point and look at how the calls are sent forward from the API gateway. When you first load the site, you do access the get schedule function, which is going to just access our Dynamo database to read the current stored. It's going into our Dynamo database and getting the table that we have here. It's scanning it and returning all the items back to the web page. And the web page builds the table dynamically based off of the JSON that it receives back from Dynamo. If we go back to the set call, or the put call, I'm sorry, it's the opposite. It's going to take the table that was sent to it from the JavaScript HTML page. It's going to read it all in, clear out the current schedule, and then turn that table that was given to it into JSON and throw that into our Dynamo database so it gets stored. Before I get into the scheduling, we could just quickly take a look at the Dynamo database. So you can see that it is a simple single table solution. We have just a single table here for EC2 schedules. If we go into that table here, we can explore the items, and you can see if I source them by ID, we have our first schedule, our second schedule, the schedules I've just put in. It's all stored here. In any one schedule that we can go into, we can actually look at it as JSON. And it's a pretty standard JSON format. There is a special format that AWS uses, looks a little bit different, but you can read it as normal JSON as well. And that's how the Lambda functions are able to read and write the data to Dynamo just by using standard JSON notation. So then once that's pretty much the interactive portion, the enhancement that I created to allow the admin of the site to be a little bit more direct with how they want things to happen, how many instances they want at any given time. Beyond that, we go into the standard starting and stopping and scaling of our EC2 instances based off of the schedule that's in there. We have the event bridge set up. Instead of hard coding specific times to do it, we wanted to read from our database, or this doesn't actually read from our database. What it does actually is in the schedule here, every 5 minutes it is running. So it's a cron job just with every 5 minutes, and all it does is every 5 minutes it calls our scale Lambda function, our scale EC2 function. Whether something needs to happen or not, that's for the Lambda function to decide. So this every 5 minutes calls Lambda, and then we can go back into Lambda to look at that scale function. And that scale function is a little bit more involved. but not too difficult to understand. It's pretty much just going to get a handle on all of our Dynamo database and everything that we have currently. The one tricky thing we did see was dealing with time zones, like the previous group mentioned. Dealing with time zones stored in the database was a little hard when working with local versus what AWS is running off of. So you have to make sure to account for that. It's pretty much going to read all of our schedules in from the database, figure out which of those schedules that the current time falls in, and then look at how many instances for that particular schedule the admin wanted, and then go and start and stop the instances to match that. So depending on how many you might currently have running, it will increase it to the right number or decrease it at any given time to match the number that the admin wanted for that time period. So it's a little bit more dynamic in a single function to be able to scale up or down depending on what the current situation looks like, how many are currently running and how many you actually want running. At the same time, we do tag all of our instances as managed by EC2 scheduler. So this function will not start and stop any additional EC2 instances that may have been running or launched outside of the scheduler function. And lastly, when it does start and stop various instances, it also pushes to SNS. So if it publishes that started or stopped a number of instances and lets you know how many of those there are. As you can see here, that it does let you know, here's one here, just refreshed. It just started 4 instances and I have a total of 4 running. It does the same thing when it turns them down as well. It terminates however many instances and tells you how many you have total still have running. That is the majority of what this does. Oh, and also, yeah, we did integrate the CloudWatch logs as well. So in the EC or in the Lambda functions, we can go in here, which was very helpful, especially learning how to talk to the database, going into the Lambda function, seeing what it was trying to do, logging various things, seeing what it thought it needed to turn, how many servers it thought it needed versus how many it thought, wanted, and figuring out how it was reading that and how to go about communicating between the various services. And it's all put together with a single, pretty much 2 IAM roles, one of which being for the Lambda function. The EC2 scheduler Lambda role gave it access to Dynamo, EC2, or Dynamo to read and write the database, EC2 to scale the servers up and down, SNS to send that notification, and CloudWatch to access all the logs. This gave most of the solution access to what it needed. The CloudFront was a little bit different. It provided its own security script that I had to apply to my S3 bucket, but it was given to me by the CloudFront, so that wasn't too difficult to understand. It provided the script. I just had to attach it to my S3 bucket, and it had access. The only other point of contention was with the API gateway. We learned that when you are running on CloudFront, CloudFront here has its own URL, cloudfront.net, versus if you were to just hit the URL, the website in S3 directly, which is an AWS URL. All the AWS functions run on an AWS URL, not on cloudfront.net. So you're on a different network here. And because of that, the API cannot speak unless you allow it access across domains. So this core section of API gateway was key to making that work. We had to enable the get and put call from any source. I could have controlled this more and put my origin directly in here, but for any source, we allowed the get and put call to come across. And once this was entered in here, it instantly allowed the APIs to talk between the CloudFront domain and the AWS domain. So all that put together allowed, a much more robust scheduler that the admin for this EC2 setup could use at any time to scale up or down as they see fit.
Very good. Give a big round. Good job.
Yeah, nice job on making it dynamic.
Very good. So a couple of questions. Really enjoy your demo and thank you for your presentation as well. I saw you have a HTML, JavaScript in S3 and you created static website. So when you're calling API gateway from JavaScript, what technology are you using? Are you using AJAX or?
No, it's pure JavaScript. You get the URL of the API gateway with that endpoint. It takes the table and converts it directly into the JSON and passes that as does a straight get or put call directly from the JavaScript.
Got it. So user point of view, user is feeding the schedule data. It goes to Dynamo. Then you mentioned, which sometimes I lose my thought, but you mentioned that you have event grid, which seems like a calling set scale function, right? Is it like 5 minutes interval?
Yes.
And does it run throughout 24 hours or certain time frame it runs?
The event bridge is every 5 minutes, it's calling the scale function to see if it needs to make a change.
And scale functions indirectly calls your Lambda.
The scale function is a Lambda.
Okay, so basically event grid is nothing but you are doing schedule for every 5 minutes call my Lambda.
Right.
And only one Lambda which is doing all the magic.
Right. Correct.
Okay. During this exercise, let's say user gives like every minute or every 10 minutes you mentioned, right? Do you see there is an overhead that Lambda will do the work and others, there will be a cycling problem, like example one, because Lambda will span out, right? If something is in progress, another Lambda will start. So one is starting. Have you experienced that?
That's why if you looked on the scheduler, I had it in 5 minute increments. Because we found that, at 1 minute increments, they could overlap. Things could still be trying to terminate while others were starting. So the HTML was reworked to only allow 5 minute increments for the start for the scheduling. And that seemed to be enough to give it time to start.
Very good. For this example, maybe you're right. But in a real life, let's assume you have 200 EC2 instance and 5 minute or maybe 10 minute schedule you have. What could be the way we can, because Lambda itself is a stateless, they don't know each other, right? So example, you fan out, scheduler will call Lambda 1, Lambda 2, Lambda 3, it might be many Lambda. How do they Lambda coordinate that, hey, something is in progress, I'm already stopping, don't do anything, we'll have otherwise racing condition. What could you do? How can you make sure you kind of stitch all Lambda such a way that they coordinate harmony? Harmony they have, otherwise you will have unnecessary chaos.
Whatever calls.
Okay, that's one way. What other options you have? This kind of questions you may expect in an interview. Why? Because first of all, you do a fantastic job. You have answer in your architecture. I just want you to think about it.
I mean, I think it could have been a little bit, one enhancement that could help with that would be to like right now we manage the tags on there, so we know which ones we start, which instances we started and stopped, but maybe we can be a little bit more direct with a tag of the timestamp of when it was started and stopped. So we wouldn't start or stop an instance that is only a few moments old. We would only target ones that have tags that are, or if there's a create, I'm not sure about the tags available. If the Lambda can detect how old an instance is, always target the oldest instance for shutting down. So that way we know we're not shutting down something that started up 2 seconds ago.
Right. So basically you have DynamoDB, right? Each and every Lambda should do the work assignment. Like example, hey, I started on this time frame. And every Lambda first make a call to DynamoDB and see, do I need to work on or skip the cycle, right? Because Lambda is stateless, but you can coordinate with them with DynamoDB, which you are using it. So DynamoDB maintain your state. Makes sense? So anytime, like example, one Lambda is about to start, you say, hey, I'm starting, I'm finishing. During this time, if any request comes and new Lambda starts, that new Lambda by default will check DynamoDB. Oh, there is already request in progress. I'm going to skip the cycle. And that type of coordination is called orchestration. You can do through DynamoDB, and it is designed for that. But wonderful one, really good. Okay, I'm enjoying these presentations. I do not have a special question, but What I'm trying to say, if you are able to do this type of thing, maybe push yourself a little bit and go get it certification. Because what you just did it here, if I give a little bit extra time and a little bit like, what you call architecture wing, this kind of things can be leveraged as a product. This can be done as a product. Because I like your JavaScript, like on demand, it's adding the content, which is great. Seems like you have development experience. Definitely. Okay.
Yes.
All right.
All right. Good evening, everyone. Today, AWS Group 1 presents EC2 automation workflow, a cost-saving architecture using Lambda, Event Bridge, YAM, and SNS to automatically schedule EC2 instance, start and stop cycles, reducing idle compute spending without manual intervention. And we're going to highlight AWS automation today. So I want to present our group. Members of our group, David Hudson, Arminda Chetman, and Irina Milihiker. And now I want to welcome Arminda to present an executive summary. I think you're muted. Arminda?
I'm sorry. Hello, how you guys doing? Of course, my name is Armanda, and I'm going to present how our group used a high-level automation cost-saving architecture to save money and to have some added benefits which you would discover. Basically, this architecture eliminates instances unnecessarily see EC2 runtime costs by automating instances lifecycle management on a 7-day schedule and a 12-hour per day. And we did that by using a tag-driven target, which is really neat because basically our resources are basically running off of tags. And this ensures that our instances can be located, they can be operated, they can be configured without going into each service and editing it, which leads me into our serverless execution with the use of Lambda functions, which handles our stop and stop logic with zero standing compute overhead. In addition, we also use the automated notification with the use of SNS that deliver real-time alerts. However, you can also use SES service, which will also give you additional monitoring tool, which would release reports, status of our systems and our machines on point. And finally, we also use the event bridge scheduling. And this tool was used to actually schedule the entire operation, to start, stop our instances, monitor our instances, and make sure that they're up and running healthy. Next, I would like to present our resource triggering tagging strategy. And basically, why we use this strategy is because it's scalable, flexible, and it's auditable. The way it's used is, of course, with our EC2s, we're tagging them with individual identifiers. With these identifiers, we leverage Lambda functions to actually communicate and to operate and start and stop our operations. Now, why did we use this type of architecture? For one, when it comes to developing and actually hammering out permissions and policies, sometimes you can run into redundancy, you can run into overlaying, you can run into our whole machines, each machine coming down, or one machine coming down. With this, we can leverage the privilege in our policies to kind of predict what's going on and to minimize the excess use. Less privilege granted, minimum access is usually the best tool to use when you're using complicated configurations that you want to run seamlessly. And in this particular model that we're using, we use the EC2 permissions set with our tags. We also use the SNS permission. And in our event and CloudWatch, we also rolled in our policies to actually consistently monitor our privileges and our permission standards. Now, when it gets to permissions, again, you have our Lambda execution role. Now, our role embedded in our role is our actual policy. It's actually a layer. We call it a layering type of effect, where, of course, you want the permission and the access there. You don't want to overly bog down security because you want it to be accessible. However, when you embed your when you identify your role, it's going to embed the policy. In addition to that, it's going to serve as our sole identifier, assuming both Lambda functions. And this is going to bind our permissions to our serverless compute layer. And as you can see, if you look at our flow, you can see that you create the role, the policy, and then it assigns Lambda, and both operates our start and stop function, which is the engine in our machines. And now I would like to introduce David, and he's going to give more details into our AW servers, and also he's going to give a live demonstration of our machines.
Thanks, Amanda. So here I want to highlight some of the core AWS services that power the automation workflow solution, starting off with the identity access management, which controls the secure access and permission across the environment. Next, we have the EC2 instances, which provide virtual compute instances that we'll be managing. Then we had Lambda, which handled the serviceless automation logic that start and stop the instances. Next, we have Event Bridge, which was responsible for scheduling and automating the overall run process. And then there's SNS, or a simple notification service, which delivers real-time notification alerts to the end user. And then we have CloudWatch, which captured overall operational logs. And lastly, CloudTrail, which we use to record all API activity, auditing, and security monitoring. Now I'm going to get in a little bit into the Lambda. This was pretty much the first part, which was the start Lambda, which primarily was to function as the identify the first EC2s and identify the instances and make sure that they were correctly automated. We then checked which instances were currently stopped and start only those instances to avoid any unnecessary API calls. After that, the instances, once they were started, the function builds a simple execution report, including instances, IDs, and timestamps. Finally, it'll send a SNS notification to inform the operations team that the start process has been completed. Then we have the stop Lambda, which function follows pretty much similar to the stop Lambda function, which targeted running instances only. The first query EC2 instance with the auto scheduler tag, which Amanda had mentioned previously, and then checks their current status. It only focuses on instances that are actively running and stop to prevent API errors. Once the stop action is executed, the function sends again an SSN notification confirming the operation has been stopped. This ensures that both the start and stop processes are automated and still providing clear operational visibility. Next, I'll talk a little bit about the SSN alert setup. This was to provide visibility into the automation process that we implemented with Amazon SNS and as our alerting layer. SSN allows the system to immediately notify operators whenever start or stop action occurs. It sets up a consistent of two particular steps. First, we had to create the SSN topic that acts as the notification channel. And secondly, we're subscribing an email addressing to the topic. Once confirmed, the Lambda execution will automatically send an alert message to the operation team. And then we have pretty much what I would consider as the main player here, which is the event scheduling bridge. Now, the automation, which was handled by the event scheduling bridge, we had two separate rules that were configured. One was to invoke the start Lambda, and then another was responsible for invoking the stop Lambda function. These rules run on schedule intervals, allowing the EC2 instances to automatically start and stop without manual intervention. And then we had the event bridge, which acts as the orchestration layer, ensuring that the automation runs consistently according to the defined schedule. And then lastly, we have here the overall architecture for this project. Again, we have the event bridge scheduler, which was responsible for triggering one of the two Lambda function, first starting with the stop and then the stop Lambda function. These would invoke the EC2 instances, which we had a total of 3 of them, starting them and stopping them. Once one starts, it will stop the other one once that's been called. And then we had the notification. So after Lambda actually runs, it actually sends a SSN notification to the team, letting them know that the instance has started or stopped. We also had that information being kicked out to CloudTrail, and the actual results of the API information being kicked out into a S3 bucket. And then we also have information in regards to the starting and the stopping of the Lambda functions, which we could track in Amazon CloudWatch, which is shown here, which we could identify by the instance IDs and timestamps of when each one of those events took place. So now I'm going to get into the actual demo, and if you allow me to change my screen. So as you see here, we have our instances are all stopped currently. What I'm going to do is go through to our event bridge, and for the sake of time, I'm going to initiate them both. But I know to give a little bit, and one of the troubles that I identified, I want to be able to demo this in class. So as far as for setting up a Chrome's schedule, what I did is actually set this up to run every 3 minutes, actually just to show the process of how it would work and show that it is working. But in a normal, I guess, business environment based on the business rules of the client, as far as when they want various processes or the EC2 to run, we would set this up, to start at, 7 in the morning and end at 12 at night. But just for demonstration purposes, this was set up this way just to show that, the event bridge can kick off the EC2 instances based on the increments that we have set here based on timing. So I'll go back to schedules, and I'll kick these both off. Enable. Let me confirm they're running. Let's see. Okay. All right. So while that's kicking off, again, it's running on 3-minute intervals. So in the meantime, I'll show, let me go to CloudWatch. Okay. So here we have two separate log groups, one for the start and one for the stop to actually track those. Currently, if I go in here, it's currently empty, but as it kicks off, this will be populated, giving us confirmation that the EC2 is being initiated. And the same goes into play as far as for the EC2 for the stop instance, it'll be updated also. So going back to the instance, as we see here, they're currently running. And I should have received a notification. Here we have our notification: start has been executed, instance has been started, and instances, or it also tells you if it's running or pending. If it was pending, I will receive the same message. And if I go back, and again, I can go to CloudWatch and I should have an updated log. Providing confirmation that, the start was a success. Also successful notification of the SSN notification being sent. So that's all you can see here. And then it also tells, the EC2 instances that were kicked off, which are highlighted here. Back. Now we can see that they're actually been stopped also. And again, I should have received a notification demonstrating that EC2 has been stopped. Okay. All right, so go back to, now I'll go back to EventBridge just to stop this from running. Let's see. Okay. And that, what I would say would be the demonstration for our project. And I'm going to turn it over to Amanda, and she's going to go over the summary and conclusion.
Okay, let me just go over the summary and conclusion. Thank you, David. That was excellent. Basically, the conclusion of our project, of course, we demonstrated quite a few benefits of using an architecture that would allow cost-saving construction in the actual machines. In addition to cost-saving, as my team and I demonstrated, we also highlighted some of the advantages, such as offering a least privilege policy that allows the need to use bases only. In addition to having a serverless event that actually you can go in, if you have modifications, you can go in without actually editing all of the services. You can just edit either the instance or you can edit the tags depending on which way or what direction you need your modifications in. And as far as the cost saving, as you can look at our presentation here, if we ran a 12-hour daily schedule, run only, it would only cost $67.80 a month versus a 24-hour daily ran machines with a cost savings of about 50%. And annually, it would be $813.60 to run on the basis of 12 hours with the stop and go method versus running a full 365 days a year with the average cost of $1,626.60, which would give us literally a 50% savings of $816. So that's pretty great in itself. And if you look at the model here, you can also see that basically you're paying for the EC2s. There's no way around it. I think one of the groups mentions there are no more free tiers, so you're going to have to pay for that. And it's good to pay for it at a cost where it's utilized and it's most efficient to have it running without any overcharges and all that. So that's the beauty of that. And as you can see, IPV fees, nowhere around that. However, you see the difference of controlling your costs versus just running full blast. You can see a significant savings there. And now that concludes our presentation. Are there any questions or suggestions?
Dig around. So questions I have, like, and Amanda, this is for you. Knowing that this kind of automations will bring cost savings, why most of the organizations are not implementing?
Well, I don't understand why they wouldn't implement it, seeing as though on some of the traditional structures, companies actually lose, according to IDC 2025 survey, $2 million a year for automation that's running, runaways, no kind of notifications that there are problems. But if you use the tag engineering, you can kind of control the operations as well as the cost. So I'm not sure why they wouldn't use it.
If someone asks you, you have done great automation, can you help us to make implement it? How do you implement it? Just doing like that, or you have to go through people, process, and technology?
No, I would implement it by first creating a template similar to the one we use now, but I would tailor it to what the problem is, what the issue is. For instance, if there was like an inventory, a company came to me and say, hey, I need an instance or two to run my inventory on a schedule, I would try to develop a template similar to this one. But instead of using SNS, I will also incorporate SES in there to make sure you get a status and a report as well.
Very good, very good. David, let's say you have implemented this and you present it to the C executive. They really like what you presented and they're asking, what else, what next? So David, what would be the next?
Next steps, I would say, would be to understand, what their business rules are and the actual scheduling that they'll be looking for as far as for their EC2 instances, having an understanding of that, and then they're being able to determine, effective timing, when it should be running, when it should shut it off, and then also, working to determine what the cost savings would be from actually, following that approach.
Yeah, so one of the smart
and there's also with the more upgraded notifications, I would say, as Armando was mentioning, that would be an effective piece. Would this just being dealing with EC2s? I just thought that dealing with the SNS notifications would be enough for it. But as far as for reporting, SESs definitely would be something additional thing to add.
Got it. But while you're presenting to the C executive, one of the smart technical persons say, David, that we have all reserve instance. Now, knowing that input, how would your cost calculations will change?
When you say reserve, I'm sorry, can you elaborate a little bit more?
Yeah, these are all EC2 reserved instances.
Mm-hmm.
Will that change or impact your calculations?
So when they're reserved, that means that they're already paying a fixed amount, correct?
Yes.
Probably, if if I can find better cost savings of going with a non-reserved and showing the cost benefit of that compared to what they currently have, then I probably would try to present it to them that way.
Very good. And Irina, for you, let's say you are doing this activity yourself, right? What are the key things you will consider while you're implementing this whole automation process?
Key components, EC2, event bridge, and notifications.
Okay, so let's say I'm like an intruder, just for example, and if I get hold of either event bridge or somehow Lambda, if I continuously stop your production environment, would that be okay?
Stop my production environment.
How would you avoid accidentally stopping the production environment? Because cost saving is good, but production impact is not good. So how would you make sure this process should not impact my system availability, especially in production environment? David, you can participate. Maybe Amanda, help your team member.
I would probably suggest designating what they call like a describable tag, and basically utilize that tag to go in and identify any problems immediately. And that tag, instead of running 12 hours, maybe run a little bit longer. Just to ensure, but that would be like one of the ways. I'm sure there are several other ways. David, can you think of something else?
So if I'm understanding this question correctly, I would say more strict permissions to be added would probably help with that.
Yes, Doc.
Just to kind of help them out, in the earlier part of their presentation, they even specified that they were using specified ARNs and they were using targeted tagging. So they already kind of said towards using the targeted tagging, but then I would also include that information that the ARNs that are associated with production would be excluded.